Oh, in this video, we're going to do more examples on integrals that involve the use of trig identities. So the first one we're going to look at here is going to be C. And in C, we're integrating cosec to the power 4x, cot to the power 4x dx. So how do we integrate something like this one? So when integrating something like this one, the first thing that you have to do is split the cosec so that you utilize the identity for cosec squared. Then this is going to be cosec squared x, and then you have cot the power 4x dx. But then recall that if you have cosec squared x, this is equals to cot squared x plus 1. And when we substitute this for one of the cosec squared terms, we now have cosec squared x cot squared x plus 1 multiplying cot to the power 4x dx. Here we can proceed by letting u be equal to cot x. When we differentiate u with respect to x, we get negative cosec squared x. So from here, dx will be equals to negative du over cosec squared x. When we perform our substitution, we're going to have cosec squared x. Where we have cot, we're going to have u, that is squared. And then we have cot again, so that will be u, but now to the power 4. Then we have du there, which will be minus, as in dx, which will be minus du over cosec squared x. Here we see that the cosec and the cosec will cancel out, leaving us with the integral of u squared plus 1 multiplying u to the power 4 du. Then the minus will come outside here. When you distribute the u to the power 4 there, it becomes negative. This will be u to the power 6 plus u to the power 4, then du. When you substitute, we're going to have minus u to the power 7 over 7, not substitute, when you integrate here, minus u to the power 5 over 5 plus c. Recall that u is cot, so this will be minus cot to the power 7x over 7 minus cot to the power 5x over 5 plus c. So this becomes our solution. So once obtained, we can move on to look at our next example, since that one is done. For our next example, we're going to look at D there. So for D, what are we looking at? Here we're looking at the integral of tan to the power 4 theta minus 1. Let's see how this one is supposed to be worked out. So for this problem, what we're going to do here is we are going to look at this expression here as a difference of two squares. Just view it as if you have x to the power 2 minus 1. If you had this, you know, to say difference of two squares would be x minus 1 and then x plus 1. In the same way, if you have x to the power 4 minus 1, you can view this as x squared minus 1 squared. So this can now be seen as x squared minus 1 multiplying x squared plus 1 as a difference of two squares. Using that idea, we can view the argument there as the difference of two squares. So this would be tan squared theta minus 1, and then tan squared theta plus 1. But don't forget, there's still that square outside. This is just based on what is inside, not that 2 outside. So from here, the idea is to introduce a sec term, because you know when you integrate, when you differentiate tan, you get sec squared. So I want sec squared to be present here. But luckily, we know that if you have 1 plus tan squared theta, this always gives us sec squared theta, that identity. Based on that, this is now the integral of tan squared theta minus 1 multiplying sec squared theta and then squared outside dx. Let's see that squared outside. When you distribute it, you now have the integral of tan squared theta minus 1 squared, and then now this is sec squared. Now, because of that square outside, this becomes sec to the power 4 theta d theta. We now have a power 4 here. I want this to be just sec squared, not sec to the power 4, because I want to let u be tan, so that when I differentiate tan, I'll have a sec squared, which will cancel with the sec here. So I'll split this into 2. So I have tan squared theta minus 1. This will be seen as sec squared theta, another sec squared theta there, d. I switched to, it was always theta. Was it? Yes, it was always theta. It's this which was supposed to be d theta throughout. So d theta here. D theta. Okay. So from here, now we'll use that identity again for sec, how it relates to tan, implying that this would be tan squared theta minus 1, and then this will be tan squared theta minus 1 again. Now this is plus, tan relates to, as in sec squared relates to 1 plus tan squared. And then we'll leave this here because this is the one we want to come and cancel when we substitute that d theta there. So here now we'll let u be tan theta, knowing that the derivative of u with respect to theta will now be sec squared theta. When we make d theta the subject of the formula, we'll have du over sec squared theta. Now we substitute. This is now the integral of tan squared there becomes u squared. And then we have tan squared again. This becomes u squared. Then the sec here will remain. This is the one that is coming to cancel with the 1 in the denominator here. So you see that we get rid of the old variable so that now we only have u as the new variable. Now from this point, we just have to distribute and then integrate this the normal way. So of course, this will be u to the power 4 minus 2 u squared plus 1. Then here we have u squared plus 1 du. Then again, distribute. We have u to the power 6 minus 2 u to the power 4 plus u squared plus u to the power 4 minus 2u squared plus 1. Like terms here, the u to the power 6 will maintain. This becomes minus u to the power 4 when you combine this and this. And u squared and minus 2, that will be minus 2 minus u squared. And then finally have plus 1 du. So integrating now, we have u to the power 7 over 7 minus u to the power 5 over 5 minus u to the power 3 over 3, then plus u plus c. Here now, remember, u was tan. We let u to be tan. So implying that this would be tan to the power 7 theta over 7 tan to the power 5 theta over 5 minus tan to the power 3 theta over 3 plus tan theta plus c. Okay, so when working out these, sometimes I tend to leave to make omissions. So if you do spot an omission, just let me know in the comment section so that your friends as well can observe that. But otherwise, the calculations, the procedure, everything is fine. Let's see if we can squeeze in one more. I think we can leave it there. Let's see if we can just squeeze in that one there. So for that one, we have the integral of sine to the power 4 3x. And then we have cos squared 3x dx. So some of these, you find that maybe you have better ways of dealing with them. So if you have something, an approach that that maybe you feel is easier and faster, let me know. I'd want to see how you would work it out using that approach. So reach out and let's share ideas. Okay, so if I'm dealing with something like this, both terms have even powers. So I can choose to combine these. So I will transform one of these to the other. So I can transform the cos into the sine. So I have sine to the power 4 3x, and then this becomes 1 minus sine to the power 2 3x dx. So using that identity, of course, since we know sine squared theta plus cos squared theta is equals to 1. So I'll just make cos squared subject. From here, this becomes sine to the power 4 3x minus sine to the power 6 3x dx. Here now you have two integrals. So you have sine to the power 4 3x dx minus sine to the power 6 3x dx. So I'll focus on the first integral here, but the method that we use to integrate the first integral will be used to integrate the second one as well. So to integrate this, I'll first start by writing it as sine squared 3x raised to the power 2 dx. Now this one, we know to say this is equal to sine, or if we had sine squared 3x, we know this is the same as 1 minus cos 2, let me use identity first before putting the x there. So let's say sine squared theta is equals to 2 theta over 2. That's what I'm going to use. So if I have this, we know to say in this case, theta is 3x, meaning 2 theta will be 3x times 2. So that sine squared 3x will be 1 minus cos 2 times 3x, which will be 6x over 2. So our integral is now just the integral of the half here can come out, can be this side. So it's just 1 minus, let me not bring it out just yet because of that square. So I have 1 minus cos 6x over 2, but remember, squared there, dx. Okay, so when we square there, this the square of course affects the 2, so let me do this. So this becomes 1 minus cos 6x squared dx, and then the 2 becomes a 4 after being squared. When we distribute that, or when you expand, this becomes 1 minus 2 cos 6x, then minus or plus cos squared 6x dx. Now don't confuse this. Remember I said I'm focusing just on the first part. You still have the second part here that you have to deal with. This one, of course, you'd have to present it as sine squared 3x, but now raised to the power 3. Of course, raised to the power 3 implies that you can actually work it out by, of course, first transform it. Yeah, I think I'll try to move it a little bit before I leave it for you guys. So that one would still have to be here. So that is sine to the squared 3x to the power 3 dx. So I'm just focusing on the first one for now. So here, of course, the first ones can easily be integrated. So this is 1 over 4. This will be just x minus. So you integrate this. This will be 1 over 3. The 6 will divide down there. Then for cos gives us sine. And then here, we're looking now just at this one, the integral of cos squared 6x dx. And then minus this one here. So to integrate this one here, again, we'll have to use that identity that we used. We just have to integrate in place of cos squared there, we'll have 1. Earlier we used, it was sine we're dealing with, but if you have cos squared theta, we know this one will be 1 plus 2 theta, or not just 2 theta, cos 2 theta, cos 2 theta over 2. Meaning, since now what we have is 6x, our theta is 6x, so this will be cos 2 times 6x, which makes it 12x over 2. So that integral there will just be integrating this term here. So this will be 1 over 4 x minus 1 over 3 sine 6x plus, when integrating that, the first part will be integrating the half. Like the best part here is that we don't, this is not raised to the power 2, so they no, not squaring anything. So the half here, I can factor it out. When we integrate 1, we get x. When we integrate the cos, this was to be positive, so it will be 1 over 12, and then the integral of cos will be sine 12x. So just verify this to make sure that I haven't made any unnecessary errors here. And then you have minus that last part, sine squared 3x to the power 3 dx. So this completes the first part. So now if you are going to integrate this one, how would you do it? Of course, the first step, I won't do the whole thing, so let me just get that one. That one is just the integral of sine to the power 3x to the power 2, I mean. And then to the power 3 dx. The first step would obviously be to split this up, so that you use that identity again, 1 minus cos, that will be basically similar to what we had earlier on. This will end up being 2 by that, which will be 6x over 2, but now raised to the power 3 dx. Then of course the 2 to the power 3, that will be 1 over 8, and then the integral of 1 minus cos 6x there to the power 3 dx. Then expand this as well, and then see how you would integrate it. But basically, the term that will end up being cos to the power 3, when you expand, one term will end up being cos to the power 3. That term with cos to the power 3, you're going to integrate it using the method we used when we integrated sine to the power 7. Since the power there is going to be odd, you're going to use the technique we used for sine to the power 7. I think when we did this in the previous video, we're going to use there, since it's going to be sine to the power 3, not sine to the power 3, to be cos to the power 3. Yes, to be cos to the power 3. So since it will be cos to the power 3 for that last step, when you expand, you're going to split it so that you have one part will be cos to the power 2, 6x. The other one will be cos 6x. So that this will be transformed into a sine, and then into a 1 minus sine squared, then let u be side, and then it's going to work out. So after you integrate both parts, after you're done integrating the one with with this one, when you're done integrating this one as well, then combine the two expressions since they're just subtracting there, and that is going to be your final answer. Okay, so I'll let you try to finish this one, but basically I've outlined everything you have to do here. If you have any trouble, let me know as well, then I'll share with you a complete solution. As usual, you can reach me through WhatsApp, and then yeah, let's say that's not 34, that is 38, 28, 1. Okay, so we can end here for this video. We'll see you guys in the next video as we do more practice.